This is the Honors Geometry exam review for Unit 4, Topic 2. Remember that you will be given a formula sheet in your exam, and you might need to use these formulas, especially with this topic right here, but it's a great reference to remember. There's 2 pages, so again, you have all of this, but for Unit 4, Topic 2, we really use that coordinate geometry part. Look at the graph of line AB on the coordinate plane below. What is the length of AB? So I'm going to use the distance formula, but that doesn't mean you have to. You can also use Pythagorean's theorem. Distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And so that's going to be 10 minus negative 10 squared plus 8 minus negative 7 squared. This is going to equal 10 minus negative 10, which is 20 squared, 8 minus negative 7, which is 15 squared. 20 squared is 400. 15 squared is 225. And 400 plus 225 is 625. Square root of 625 is 25. So AB is going to be 25 units long. If you wanted to, though, you could have found the length of this and the length of this and done a squared plus b squared equals c squared. That is what the distance formula is. It is Pythagorean's theorem. For 46, point C is between points A and B and has coordinates 2, 2. What is the ratio A to C to B? Well, we can see 2, 2 is right here. And if we want to do this graphically, I'm going to look at where all of my points cross at integer coordinates. So I can see right here, right there at 2, 2, and right here. And we can look and we can see this is going up 3 and over 4. Up 3 over 4, up 3 over 4, up 3 over 4, up 3 over 4. So I've split this line into 5 equal parts. I'm looking at C, which is at 2, 2. So what I can see is that A to C is 1, 2, 3 parts, and C to B is 2 parts. So AC to CB is going to have a ratio of 3 to 2. Now that being said, another way to do it is find the length between AC. So doing the distance formula, x2 minus x1 squared plus y2 minus y1 squared, that's going to equal 2 minus negative 10 squared plus 2 minus negative 7 squared, which equals 2 minus negative 10 is 12, 12 squared. 2 minus negative 7 is 9, so plus 9 squared. This is the square root of 144 plus 81, which is going to equal the square root of 225, which is going to be 15. I could then find the distance of CB, which, again, using that formula, x2 minus x1 squared plus y2 minus y1 squared, I'm going to have 10 minus 2 squared plus 8 minus 2 squared equals the square root of 8 squared plus 8 minus 2 is 6 squared, which equals the square root of 64 plus 36, which equals the square root of 100, which is 10. So looking at the ratio of AC to CB, that is a distance of 15 to a distance of 10. If I divide both sides by 5, I get 3 to 2, which is the same ratio. With 47, it says determine the coordinates of point D so that the ratio A to D to B is 1 to 4. Well, the easiest way to do this is graphically, where I can see 1 let me go down here, 1 to 4 is going to be a total of 5 parts, meaning that A to B is going to be 5 parts. So I want AD to be 1 part of this line of AB, and I want D to B to be 4 parts. Well, since we already divided the line into parts, and we can see it's 1, 2, 3, 4, 5 parts, what we really want is this to be A to D, and this to be D to B. This breaks it into 1 to 4. If that's true, then this will be D, which is going to be at the point -6, -4. So my coordinates for point D is going to be -6, -4. For question 48, look at line K, whose equation is y equals 3x minus 2 on the coordinate plane below. So given the equation y equals 3x minus 2, I can see that my slope is 3, or 3 over 1, and my y-intercept is -2. What I'm going to do is write equations for the following lines. I want a line parallel to line K passing through the point 0, 2. So parallel means that we have the same slope. So that means that m is going to be 3. Now, if I realize that 0, 2 is the y-intercept, then I can make my equation really quick. But let's say that you don't realize that. Our equation of a line is y equals mx plus b. I know that my slope is going to be 3. So I need to find what is b to make this line that passes through the point 0, 2. So I'm going to plug in the point 0, 2, y equals 2, 3 times x, which is 0, plus b. Well, 3 times 0 is 0, and 0 plus b is b. So 2 must equal b, and my equation is going to be y equals 3x plus 2. So this is the equation of a line that is parallel to this line. Next, I want a line that's perpendicular to line K, passing through 0, -5. Well, perpendicular means that I need to find the negative reciprocal of my slope. So if my slope was 3, I'm actually going to look at this as 3 over 1. My new slope is going to be the negative and the reciprocal of that, so -1/3. Again, if I realize that this is the y-intercept, I can go straight into writing the equation. But here we're going to have y equals mx plus b. So y equals -1/3 x plus b. I'm going to plug in the point 0, -5. So y is going to be -5. I have -1/3 times x, which is 0, plus b. -1/3 times 0 is 0. 0 plus b is b. So -5 is going to equal b. And my equation is going to be y equals -1/3 x minus 5. And this line is perpendicular to the line up here. Items 49 through 52, and this item continues on the next page, uses the quadrilateral below. Kelly thinks that the figure might be a square. Remembering her geometry, she does the following. So we'll look at question 49. Kelly first needs to know if the figure is a parallelogram. Show that the figure is a parallelogram by showing that the slopes of opposite sides are equal. So let's first start with the slope of AB. Remember that slope is y2 minus y1 over x2 minus x1. And AB, my My points are 1, 4, and 5, 1. So I'm going to do 1 minus 4 over 5 minus 1. 1 minus 4 is negative 3. 5 minus 1 is 4. Now I'm going to find the slope of its opposite side, which is CD. Again, y2 minus y1 over x2 minus x1. So negative 3 minus 0 over 2 minus negative 2. Well, negative 3 minus 0 is negative 3. 2 minus negative 2 is 4. And we can see that they're the same. So we know AB is parallel to CD. Now we have to look at the other set of opposite sides. We've got the slope of BC, which is going to be y2 minus y1 over x2 minus x1. So I'm going to do negative 3 minus 1 over 2 minus 5. Negative 3 minus 1 is negative 4. 2 minus 5 is negative 3. This simplifies to 4/3. The slope of its opposite side, which is DA or AD, is y2 minus y1 over x2 minus x1. So 0 minus 4 over negative 2 minus 1. 0 minus 4 is negative 4. Negative 2 minus 1 is negative 3. And this simplifies to 4/3. Therefore, we can also see that BC is parallel to AD. And we've shown that this is a parallelogram. For question 50, Kelly now wants to determine if the figure is a rectangle. There are two ways to do this. So part A says, show by using slopes that one of the angles is a right angle, and therefore there are 4 right angles and the figure is a rectangle. Well, if we look back at this, I'll just pick side AB and BC. So the slope of AB, which we already calculated, is negative 3/4. The slope of BC is 4/3. And what we know is that if negative 3/4 times 4/3 equals negative 1, then the slopes are negative reciprocals of each other and the two sides are perpendicular. Well, negative 3 times 4 is negative 12. 4 times 3 is positive 12. So this is going to equal negative 1. This tells us that AB is perpendicular to BC because the slopes are negative reciprocals and the product of the slopes is negative 1. And if one of the angles is a right angle, then all 4 are right angles. You could have picked any two adjacent sides to see if they were perpendicular. For part B, it says show that the diagonals of the parallelogram are congruent and the figure is a rectangle. So we need to see that AC has the same length as BD. So just because I can't see the picture here, I'm going to write down my points. A is 1, 4, and C is 2, negative 3. So I want to find the distance of AC. That's one diagonal. And then B is 5, 1, and D is negative 2, 0. And we also want to find the length of BD, which is the other diagonal. To find the length, I'm going to use the distance formula, which is x2 minus x1, the square root of x2 minus x1 squared plus y2 minus y1 squared. So this is a square root of, and I'm going to do 2 minus 1 squared plus negative 3 minus 4 squared. This is a square root of 2 minus 1, which is 1 squared, plus negative 3 minus 4, which is negative 7 squared. This gives me the square root of 1 plus 49, which is the square root of 50. For BD, we're going to use the same formula, square root of x2 minus x1 squared plus y2 minus y1 squared. So this is the square root of negative 2 minus 5 squared plus 0 minus 1 squared. So this is the square root of negative 2 minus 5 is negative 7 squared. 0 minus 1 is negative 1 squared. This gives me the square root of 49 plus 1, which is the square root of 50. So I can see that AC is congruent to BD, meaning that the diagonals of the parallelogram are congruent, and therefore the figure is a rectangle. Question 51. Now that Kelly knows the figure is a rectangle, if she can show that it is a rhombus, then it must be a square. Again, there are two ways to do this. Part A says, show that all four sides are the same length, and therefore the figure is a rhombus. This means that we need to find the length of AB, BC, CD, and DA. Since the coordinates are on another page, I'm going to write them out again. We have A, which is 1, 4, B, which is 5, 1, C, which is 2, negative 3, and D, which is negative 2, 0. So we need to find the length of AB, BC, CD, and AD. And if they're all equal to the same length, then the figure is a rhombus. So remember, the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So, square root of AB, that's going to be 5 minus 1 squared plus 1 minus 4 squared. Well, the square root of 5 minus 1 is 4 squared, plus 1 minus 4 is negative 3 squared. So this is going to equal to the square root of 4 squared, which is 16, plus negative 3 squared, which is 9. 16 plus 9 is 25, so the square root of 25 is 5. BC, the square root of 2 minus 5 squared plus negative 3 minus 1 squared. This is going to be equal to 2 minus 5, which is negative 3 squared, plus negative 3 minus 1, which is negative 4 squared. This is equal to negative 3 squared, which is 9, plus negative 4 squared, which is 16. 9 plus 16 is 25, and the square root of 25 is 5. CD, we have the square root of negative 2 minus 2 squared plus 0 minus negative 3 squared, which equals the square root of negative 2 minus 2 is negative 4 squared plus 0 minus negative 3, which is negative 3 squared. So negative 4 squared is 16, negative 3 squared is 9, square root of 16 plus 9 is the square root of 25, which equals 5. Finally, the length of AD. So the square root of negative 2 minus 1 squared plus 0 minus 4 squared. This is going to be equal to negative 2 minus 1, which is negative 3 squared, plus 0 minus 4, which is negative 4 squared. So this is the square root of negative 3 squared is 9, negative 4 squared is 16, 9 plus 16 is 25, square root of 25 is 5. Therefore, we know that AB is congruent to BC, which is congruent to CD, which is congruent to AD. So we have proven that it is a rhombus. Part B says, show by using slope computations that the diagonals are perpendicular and therefore the figure is a rhombus. So we need to find the slope of our diagonals. Our diagonals are AC, so we're going to find the slope of AC, and we're going to find the slope of BD. Well, remember, slope is y2 minus y1 over x2 minus x1. AC, so negative 3 minus 4 over 2 minus 1. Negative 3 minus 4 is negative 7. 2 minus 1 is 1. This is going to equal negative 7. BD, y2 minus y1 over x2 minus x1. This is going to be 0 minus 1 over negative 2 minus 5. 0 minus 1 is negative 1. Negative 2 minus 5 is negative 7. This simplifies to 1/7. If they are perpendicular, that means their slopes are negative reciprocals of each other. That means that their slopes, when multiplied together, equal -1. Well, -7/7 is -1, so this works. This means AC is perpendicular to BD, and we have yet again shown that the figure is a rhombus. Finally, Kelly also remembers a property of parallelograms that the diagonals bisect each other. Show that this is true by determining the midpoint of each diagonal and showing that each midpoint has the same coordinates. So again, I'm sorry, I have to write this. Our 4 points are A, 1, 4, B is 5, 1, C is 2, -3, and D is -2, 0. So we want to find the midpoint of our diagonals. So we want to find the midpoint of AC, and we want to find the midpoint of BD. Well, the formula for midpoint is x1 plus x2 over 2, so the average of the x's and the average of the y's. So for AC, we have 1 plus 2 over 2 and 4 minus 3 over 2. This is going to simplify to 3/2 and 1/2, or 1.5 and 0.5. So that is our midpoint for AC, the diagonal AC. The midpoint of BD is the same formula, x1 plus x2 divided by 2, y1 plus y2 divided by 2. So I'm going to be adding 5 minus 2 over 2 and 1 plus 0 over 2. 5 minus 2 is 3/2. 1 plus 0 is 1 over 2, which also equals 1.5 and 0.5. So we've proven that the midpoints of AC and BD, which are our diagonals, are the same. So our diagonals bisect each other. And this proves another property of parallelograms. For items 53 and 54, determine the area and perimeter of each shaded figure below. Each grid line represents 10 meters. Let's start with the area. Since this is a compound figure, I'm going to split my area into 2 parts. I've got part 1 here and part 2 here. So the area of both of these is going to be base times height, since they're both rectangles. My base for problem number 1 is 40, and my height is 60. So I'm also going to have 40 here. Just to go around the figure, because I'll have to do this for the perimeter, this little part right here is going to be 20. This is going to be 50 up here, and 80 down here, and 50 across. So the area of 1 is base times height. My base is going to be 40 meters. My height is going to be 60 meters. 40 times 60 is 2,400, and meters times meters is meters squared. For number 2, the area is also going to be base times height. We're going to have 50 meters times 80 meters. Whoops. And 50 times 80 gives us 4,000, and meters times meters is meters squared. So my total area is going to be 2,400 meters squared plus 4,000 meters squared, which is going to give us 6,400 meters squared. So my area is going to be 6,400 meters squared. My perimeter is going to be the area around. So 60 plus 40 plus 20 plus 50 plus 80 plus 50 plus 40. So my perimeter is going to be, as I said, 60 plus 40 plus 20 plus 50 plus 80 plus 50 plus 40. And when I add these numbers together, I'm going to get 340. Sorry, these are all meters. So I'm going to get 340 meters. And that is my perimeter. For question 54, to find the area and perimeter, I'm again going to break it up into two parts. I've got one, and it's a little hard to see, and I've got two. Maybe I'll change the color. There we go, 1 and 2, and I'm breaking it up right here. So again, I'm going to find the length around each part. So this is going to be 40. This is going to be 80. We have 40 down here. We have 60 down here. And now we have to find this length. The easiest way to find this length would be to do Pythagorean's Theorem, where I have a squared plus b squared equals c squared. 60 and 80 are my legs, so 60 squared plus 80 squared is going to equal c squared. Well, 60 squared is 3,600. 80 squared is 6,400. When you add them together, you get 10,000. And when you square root that, c is going to equal 100. So my length on this side is going to be 100. Now, to find my areas, the area of 1 is going to be a triangle, so 1/2 base times height. So I'm going to have 1/2, my base, which is 60 meters, times my height, which is 80 meters. Well, 1/2 of 60 is 30 meters, times 80 meters, and 30 times 80 is 2,400 meters squared. My area for 2 is a rectangle, so I'm going to do base times height. So my area is going to be my base of 40 meters times my height of 80 meters. Well, 40 times 80 is 3,200 meters squared. So my area is going to be 2,400 meters squared plus 3,200 meters squared. And this is going to come out to an area of 5,600 meters squared. So my area is going to be 5,600 meters squared. My perimeter is going to be the area around. So I don't have much space. I'm going to do it up here. My perimeter is going to be 60 meters plus 100 meters plus 40 meters plus 80 meters plus 40 meters. So what I've done is 60 plus 100 plus 40 plus 80 plus 40. And this adds up to 320 meters. So my perimeter is going to be 320 meters. And that is the end of the Honors Geometry Unit 4, Topic 2 exam review.